Hi, in this video we are going to see how to convert the given push-on automata to context-free grammar. The push-on automata is normally represented by a tuple having set of states Q, input symbols, stack symbols, transition functions, initial state and initial stack symbols. So in this example we are having set of states Q as Q and P. Two states are here and input symbols 0 and 1, stack symbols X, Z, and in addition to that the input symbols will also be added here, and the initial state is Q. Out of this Q and P, this Q is taken as the initial state, and Z0 which that is initial stack symbol is Z. Okay, so our objective is to find the equivalent grammar for this PDA. So this grammar is normally represented by a tuple having set of variables, input symbols, set of productions and start symbol. This set of variables will be explained later. Now this input symbol is going to be the same as input symbols of push-on automata. So here we are having 0, 1. So the same will be taken here. And the set of productions will be explained. Before that, this start symbol, that is the initial symbol which is to be taken for any context-free grammar, is represented here as special symbol which is yes. Okay, so in addition to this start symbol, we may have n number of variables. So all these variables will be represented as a 3 set of components. One is P, X, Q. There where this P and Q are states of Q and X is the stack symbol. Now let's see the rules to convert PDA to CFG. The first rule for conversion of PDA to CFG is for the starting symbol we have to write the productions, right? So for this starting symbol the productions has to be written like this, that is Q0 Z QI. So here Q0 is representing as in the initial state and Z is the initial stack symbol, and this QI is coming from, it's a set of, it is representing all the states of this Q, right? So the second rule is, in case if any of the transition function is represented like this, del of Q comma A comma X is equal to R comma Y1 Y2 YK. That means you may have n number of input symbols on the stack, right? So it may be having push operations, or it may pop out some of the value from these elements, or it may have no change in this, right? So there are 3 options possible. But here we are taking this X is represented by, or X is replaced, the X which is presenting on the stack is replaced by Y1 to YK variables. So in general this description or this transition function is represented like this. For this transition function, the equivalent state symbol, start symbol productions or the equivalent productions for any symbols will be taken by like this, in this format, right? Q, X, R, K. So let's see how to represent this. The Q is the state at which we are having now, right? At which we are now, right? That is Q. And this stack content, that is the topmost stack symbol, should be represented here as the second component. And the third one is going to be the one which is taken from the last states of this, because when we start processing each and every element of this, you may have to move from one state to another state. So all these intermediate states are going to be represented here like this. So after processing Y1, it may go to one intermediate state R1. From this R1, it process Y2, and then it will go to R2, and like that it keeps on going, and finally it will process YK and it will reach RK. Okay, so this component Y1 to YK is represented by set of symbols. No, sometimes this K may be 0. In case if this K is 0 means it will be having only epsilon. Okay, and in the case if it is having epsilon, this transition functions will be represented like this. Q comma A comma X is equal to R comma epsilon. So when we write production for this, we have to take this Q as such, and then stack symbol and the state R as such, right? And it will produce this input processing symbol which is A. Okay, and in case if you have epsilon in this input symbol, then the same production can be written as QXR. That means QXR produces epsilon. So with the help of these rules, we are going to see how to convert the transition functions of PDA to productions for G. In the given example, we have six transition functions. For these six transition functions, we have to see the respective productions. In addition to that, we should see the productions for starting symbol. For the start symbol, the production should be written as S produces the initial state of PDA, initial stack symbol of PDA, followed by the combination of all states. So as we have two states here in this PDA, for the first production is going to have a Q and the second production is having P, right? So S10 produces QZQ. That should be given as one of the variables, and the second one is second production for S is S produces QZP. Okay, now we have to see the productions for the first transition function. Del of Q, 1, Z is equal to QXZ. So, as per the second rule, we have two symbols here, right? So, that means K is equal to 2. Now, we should substitute R2 here, and here the intermediate state is R1. Now, we are representing here, these variables are represented here as P2 and P1. Okay, so the destination state is P2 and the same destination state is given here, and the intermediate state is P1. So we are having two states in this queue. So we have to see the combinations of these two states with respect to this P2 and P1. So both can be Q, or one is P2 is Q and this one is P, or this one is P, P2 is P and this one is Q, and both are P. Right? So let's substitute the P2 and P1 with these combinations. So let's copy this QZ as such, and then the input symbol 1 and this QX as such and this Z as such, right? The only thing which should be substituted here is P2 is substituted as Q. So in both the places we are substituting Q, and P1 should be replaced by Q, right? So here this P1 is Q. Right, that intermediate state is processed, right? Next one is, and the next combination is Q comma P. So the second P2 is Q, right? So P2 here Q and P1 is P. Okay, and for the third combination, the destination state is P, right? That is P2 is P. So P is copied here, and the intermediate state is P1, which is Q. Okay, and in the last state, both P2 and P1 are P. So this P2 is given as P and the intermediate state is P. Okay, so in the same way, the second transition function is also having two symbols on the stack. So we are having the destination part. That means in this del of Q, 1, X, it's generating the instantaneous description as Q, XX. That means it is pushing X onto the stack. So the same procedure to be followed. We have to substitute P2 here and the intermediate state P1 should be processed here. The same combinations of P2, P1 should be taken, and this QX, the Q is taken from this initial state and this X is taken from the topmost stack symbol, and the processing, that input symbol which is to be processed should be taken here in this leftmost terminal of this body of the production, and here we have to take this Q state, and this stack symbol should be the stack symbol, or what we are having here is X and X, right? Two stack symbols are there. So that is taken here, and the intermediate state is taken from this P1, and this is taken from P2. So these two are P2 and these two are P1. Substitute this. Now we have four different productions. Now let's see the third production. So in this third one, the transition function for this PDA is del of Q, epsilon, X equal to Q, epsilon. As we said, if K is equal to 0, it produces epsilon. In this rule 2, we have already seen this one, right? So in this rule 2, we have seen this production. No? So according to this, we are taking Q, the stack symbol is X, and the destination state is Q, produces this input symbol epsilon. Okay, because we don't have any terminal here, it is having only epsilon, the same will be substituted. Now let's take the fourth production, a fourth transition function. So del 4 is del of q comma 0 comma x equal to p comma x. That means here k is equal to 1. So q, x and the destination state is here this destination state will be copied here and this tag symbol is copied here. Sorry, this tag symbol is copied here and here we have to substitute all the states of q. Okay, as we are having two states, let's substitute q for the first production and p for the second production. Okay, and fifth production is fifth transition function is p comma 1 comma x equal to p epsilon. So here k is equal to 0. So p x p produces 1. Okay, this input symbol should be copied here. Okay, the last production is sixth one is del of p comma 0 comma z is equal to q comma x, q comma z. It is same as this one. So we have to take the starting state, this tag symbol, and this state should be taken here. This tag content should be taken here, and it has to move to one destination state. As it is processing only one symbol, it will be having only one destination state p1, and there is no intermediate states. So the combinations of that one is q and p. So that will be replaced here. So we are having p in this and q in this. So we have seen productions for all the transition functions. Now we have to simplify these productions. So as I said, for each of the variables we have to write the respective productions. No, so first let's list out all the productions. So the starting symbol is right. Next, all the states of all the variables of this production. So when you take these variables, we have to take the middle element as the stack symbol, and this first and last component is going to be the states of q, right? So in this we have q and p. So we are taking the initial stack symbol first and then second stack symbol x, right? So the combinations are qq, qp, pq, pp, right? Similarly, for the second stack symbol, we have qq, qp, pq, pp. So as we have two states, we are getting 2 to the power 2, 4 combinations, and we are having two state symbols, stack symbols. So we are having 4 into 2, 8 states. In case if we are having 3 states, means we have to take accordingly. Now we have to see the productions one by one, and then we are going to replace that production states by the new name, right? So the new names are given here. This S is taken as such. This QZQ is represented as A. The next one as B, C, D, E, F, G, H, right? So let's take the first production. For the start symbol, we found that it is S produces QZQ. So what is the new name for QZQ? It is A. So we are replacing this S production as S produces A. What is the alternative production for S? S produces QZP. The QZP is B. So S produces A, alternate production R, B, right? So we have two productions for S which is represented here. So these two are done. Now let's see the transition function first, one, right? So for this we have found 4 productions now. So let's take one by one. So QZQ. So the QZQ is A, right? So we are taking, okay. Now let's see the second, that is first production, first transition function. So for this we have 4 set of productions. So QZQ. QZQ is A, right? A produces QXQ. QXQ is E. So 1 E and QZQ is A. So A, right? So similarly for the second production QZQ. QZQ is A, right? A produces 1. QXP is F, right? So F, and then PZQ. PZQ is C. So C is substituted here. and the remaining two productions are QZP. So QZP is B, right? B produces 1 and QXQ. QXQ is E and QZP. QZP is B. Okay. And for the second production, that means QZP. For this QZP itself, we have two productions. So QZP, B produces 1. Okay. 1 is done. And QXP. QXP is F. So F and then PZP. So PZP is D. So D. Okay. So this is for first transition function. Similarly, for the second transition function. So for this second transition functions, we are having two productions for QXQ. QXQ means E. And similarly, we are having two productions for QXP. This is F. So we have two productions for E and F. For the first one, it is 1 and QXQ is E, and this is also QX Q, right? So that means, this should be QXP. So here we are having 1E and F, okay? And 1E, this one is 1EE, okay? And similarly, for the second production for E is 1, F is QXP, and this PXQ is G, okay? So we are having these two productions for E. Now, for F production, it is 1 E and this QXP is F. So, 1 EF. And for the second production, it is 1 and QXP is F. Okay. And PXP is H. That's done. Okay. And for the fourth transition function, for this fourth transition functions, we have QXQ produces epsilon. So QXQ is E, produces epsilon. So the alternate production is added. And for the fifth transition function, it is QXP. So QXQ produces 0 PXQ. So QXQ E produces 0 G. Okay. Similarly, QXP F produces 0 H. Right. So these two are done. 0 H. Okay. And for the last one, last two are PXP produces 1. So PXP is H produces 1 and this one is PZP. So PZQ and PZP, that means C and D. C produces 0 and this one is QZQ is A. Okay. Similarly, PZP produces, that means PZP is B, no? So B produces, PZP, that means D. D produces 0 and QZP is B. Okay. So likewise, we are taking all the productions for all the symbols. So out of all these symbols, this G has no productions. So if you don't have any productions for any variables, we can eliminate those variables. So we are eliminating the variables G which is present in these two productions. So the productions for E can be minimized as E produces 1 EE. This production has been taken and epsilon production alone is taken. These two will be eliminated. We don't have G in any other productions. So this is all about conversion of PDA to CFG. Thank you.